Let's compare and contrast the properties of the conic sections we've looked at. So, I'm going to look at parabolas, ellipses, and hyperbolae. And yes, we did mention circles, but circles are a special type of ellipse. So, for a parabola, it has one focus, and it has one special line, which is called the directrix. And it looks like this. An ellipse has two foci. It has no special line. And it looks like this, with those being its two foci. Hyperbola has two foci and two asymptotes. And the foci are there. In the equation, a parabola has one of the variables is going to be squared. Either x is going to be squared or y is going to be squared, not both. For an ellipse, both x will be squared and y will be squared, also in a hyperbola. We can look at the discriminant, b squared minus 4ac, to determine what's happening with the conic, and if b squared minus 4ac equals 0 and a equals b, sorry, a equals 0 or c equals 0, then we call it a parabola. It's an ellipse if the discriminant is negative. Another way of looking at this is saying that AC is positive. And for a hyperbola, typically this is the case. This is when we have b, if b is equal to 0. And for a hyperbola, the discriminant needs to be positive. So this is like saying if b equals 0, AC has to be negative. For a parabola, you need to know that 4p is the distance to the focus, whereas in an ellipse, you have c squared equals a squared minus b squared, where a is the half of the length of the major axis, b is half the length of the minor axis. And for a hyperbola, c squared equals a squared plus b squared. A horizontal, I'm going to give some examples of horizontal and vertical ellipses, as well as horizontal and vertical hyperbolae. So they all look vaguely like this. For a horizontal ellipse, this number is bigger than that number. So for a vertical ellipse, the denominator on y is bigger. For a hyperbola, a horizontal ellipse, it doesn't matter which one is bigger. It matters that this is first, that x squared is the positive part. Because in a vertical ellipse, y squared is first and x squared is the negative part. Now, they don't have to be the same number, but I'm trying to show that it doesn't matter which of these is bigger, but it does matter if you think of that as -4, this is negative, this is positive. So this, we're going to look at identifying some conics. So this is an ellipse. This is a hyperbola. This is a parabola. If the foci are further apart than the vertices, so we have vertices and then the foci are further out, that's going to be a hyperbola. But if the foci are closer together than the vertices, then that's an ellipse. Each point is the same distance from a specific point and a line. So that's a parabola. Each point's total distance to two foci is constant. That would be an ellipse. Each point's difference in distances to two foci are constant. That's a hyperbola. And if we look at b squared minus 4ac, we can say here we have b squared minus 4ac, we have 16 minus 4 times 8 times 2. So 16 minus, what is this, 64? So that's less than 0, so that we know that this one will be an ellipse. Here, b squared minus 4ac is 9 plus 20, so that's greater than 0, so we should say that this is a hyperbola. And here, b squared minus 4ac. Now, it's tempting to say that, oh, b is negative 105 and c is negative 512, but b has to be the coefficient of x squared, c has to be the coefficient of y squared. So this is giving us 0. This is a parabola. And you could also see this in the sense that there's an x squared, but there's no xy or y squared.